Hi, my name is Mike Ferron-Jones, and today we're going to talk about persistent memory programming using the non-volatile memory libraries. So for decades, we've had two tiers where data can be stored. In volatile memory, we have very high performance, but relatively high cost. On the other tier, we've got storage, which is very large and non-volatile, but it tends to be lower performance than memory. Developers today are well-versed in a two-tier model, but persistent memory changes that. It's like you introduce this whole new third tier that brings together non-volatile storage with the performance of traditional memory. There have been persistent memory products on the market for several years, but they've been somewhat limited based on low capacity and relatively high cost. With emerging technologies such as Intel DIMMs based on 3D XPoint, we think persistent memory is on the verge of going completely mainstream with large capacities and very affordable cost. Persistent memory opens up some amazing new possibilities for developers, but it also creates some new challenges. The first challenge is, what am I going to do with this amazing new technology? The second challenge is, how am I actually going to execute this in my code? The libraries that are available today were created on the assumption that you're working in a volatile memory world. Persistent memory completely turns that on its head, and that completely changes the way that you conceive of programming the system. At Intel, we want to remove the barriers to persistent memory programming. We want to make it fast, easy, and familiar. And so we created the Non-Volatile Memory Libraries, or NVML. NVML is a suite of libraries that provide tested and optimized operations for persistent memory programming that really reduce application development time. It's open source, and it's based on industry standard programming models. You can think of it as an accelerator to get you into this new world of persistent memory. NVML contains libraries that help developers address many of the fundamental requirements of persistent memory, things like power fail-safe transactions or managing persistent memory allocations. It also contains libraries to help address many of the emerging use cases that we see coming, such as in-memory databases. Today, an in-memory database is stored entirely in volatile memory. Imagine you're doing analytics on a huge amount of data. If you can load all of your data into persistent memory, that's much more efficient than using the traditional storage tier, because now you're doing everything at memory speeds. And because it's persistent, you don't have to reload the data every time you reboot your machine. For data sets that are potentially terabytes in size, persistent memory can literally save you hours of restart time. NVML delivers a wide variety of benefits, but most importantly, it simplifies the complexity of persistent memory programming. Developers have told us that they have saved weeks of low-level memory management programming and instead able to focus on what's really important, delivering value and innovating in this new world of persistent memory. NVML is free, open source, and available today for both Windows and Linux environments. And we're constantly updating it, adding new features and capabilities. For developers who want to be on the cutting edge, NVML is going to be your fast track to the future. If you'd like to learn more about NVML, please visit us at pmem.io or connect with us at software.intel.com.